Alright, this is what we have so far for the database final. For SQL, just to make the data workable, we all had something kinda similar to this. It just gets the average fare for each day and then groups them together, and we would separate it for each, or I did it anyways, where I separated it for each particular flight. So I had a separate table of each flight from each year with the average fare for each day. And then me and Steven did 2023 and 2025, but Dane did a lot more years than that. But there's just some baseline graphs of the average fare for each day for each year of each flight.
So I used only 2023 to predict 2025 values, and the graphs look kind of nice, but the RMSEs don't. For my best one was the JFK one, where the RMSE was 38.32, but that Boston one is over 100. So but I essentially, to get the equation to find the values, I just used the data solver regression line using the 2023 and 2025 values, and the p-value I got for one of the predictors was like very, very close to 0, so according to that it was pretty good, but
The p-value for what?
the p-value for like I think it was the MSP to DFW predictions. When I used the 2023 value to predict the 2025 value, the p-value was
25 value of what? MSP to
yeah,
DFW?
yeah.
You use 2023's
Data,
data to predict this year's results.
Yes. And because I was thinking, well, my thought process was usually, from what I've seen, the only thing that really changes a flight's cost over years, and except if you have a pandemic, is inflation.
Yeah.
For the most part. So
maybe
I thought
maybe the pattern is exactly the same every year.
And I found it really was.
And you were using raw data.
Yeah,
just the raw values, and it just added the inflation in on itself.
No, I didn't add any.
Yeah.
But it
figured out what the inflation was.
Yeah. So and it was really good. The values are close to each other, and except that I found our data goes further than the 2023 values. So past November 6th, the prediction gets not as good. Which is why a lot of especially for I guess the MSP to DFW predictions, the values are much lower than what the values actually were.
So exactly what are you using? Are you saying I want to predict September 25th, 25 airfare, and you're using September 23rd, September 24th airfare from 2023? Are you just using one point, or are you using multiple values?
I'm using
how many input columns? How many X's to predict your Y?
Oh, I was only using the 1 and 1 because I was like, if I tried to use 2019 or...
You're using a naive model from 23 to predict 25?
But I noticed that after I made the graphs that I did that, and I was like, oh, and I forgot.
Well, actually, I mean, I kind of love that it's a year apart, because now it shouldn't look lagged.
No, it's not. I noticed that. Yeah, it didn't look lagged, but
crap.
Yeah, but I wasn't going to use the 2019 or 2021 because of the pandemic and the prices for.
Well, if it's handling inflation in its guesses, it might handle deflation from the pandemic.
But yeah, that was most of my prediction model.
For my model, I used the previous 3 classes data. So I used the average fare for the day I was predicting with the 3 classes and one day in the future, but the p-values weren't very good. for that date in the future. I also use the slopes for those three classes and this year's, using 4 days before and 1 day before to get the slope.
Okay, so what I'm getting from this presentation, actually, I guess you're telling us what attributes you used, but yeah, when you give this presentation for real a week from now, when you say I use these three things to predict the next day fair, show us what those three things are, and also give me the p-values of those three things, just so you don't have to say, well, they weren't very good, but we don't know what that means. Show us that the p-value is 0.6 or 0.3, and really you were looking for 0.05. All right, so it looks like you use some of those. I don't know that Stephen's model is up there. 1 day before, 1 day until departure.
No, all of my models were on the
Okay,
previous slide.
so you just described it in words.
Yeah.
Yeah, okay. So for the final presentation, when you're talking about those models, show us what you would have said in words. Just so we can copy it on our next report and use it to impress our bosses in our job interviews.
And my last attribute was days until departure.
Yeah. So the smaller that number gets, probably the higher your price is gonna get, because it's figuring out that prices go up as the day gets closer and the plane is filling up. But yeah, that's I think that's probably a pretty good input.
So we got.
All right, next group. Team Culver.
What we have so far. So our plan, we're gonna keep things simple. We're gonna use our 25 fairs. We're gonna create a separate graph for each of our 3 flights, fair history, as well as our predicted series, and we'll use linear regression to do this.
For the pre-processing, the original database, we're writing separate SQL queries for each destination. These queries grab the data from the fare table, where destination equals DFW, or switch it out for whatever destination. Now we got the data that we need isolated, and I tried pasting this into Excel and using the average function to generate a value of like the average fare per one given day, instead of having like multiple fare prices on the same day. And then I also created a new column called date number, which is basically like the infno from homework 5.
But you know what it also is, Laura?
Huh.
If we're gonna steal Dane's idea, and we wanna say, okay, number of days before departure date, if your date no's go from 1 to 150, then 150 minus your date no is going to be Dane's days until, and that might actually be a good input.
Okay.
Just take his input, yeah.
Well, take good ideas, that's what today's presentation is about.
So the next steps, continue creating these average fare values per one day. Excel using the average function is taking way too long, so gonna figure out a way to write some code to make it easier. After I get that done, then put it all back into Excel, use linear regression to generate the predicted fare values. Then graph the actual fare versus predicted fares for each of the destinations. and then use some more equations to figure out the RMSEs and see how accurate our predictions were versus the actual values. And that's it.
No graphs? You know I love a presentation with a graph.
Oh, we're saving the best
Oh,
for the final,
okay.
yeah.
It won't be as nice if you see it.
Yeah.
No.
Great, don't want to spoil it.
Christmas Day.
All right. I made my suggestion about date notes. Oh yeah, and what I would love to see in next week's presentations is if or days until departure worked really well for one group and didn't work so well for another group, and we're going to be able to see that if when you show us your graphs, you also show us these were the p-values for these inputs, and so that sort of tells us which of the inputs was most important. And if you really have a golden input, I mean some sort of silver bullet magic column of values that helps the prediction a lot, it might actually make something like days until departure, which is useful for somebody else, less important for you, because you're getting all of your functionality, you're getting all of your results out of something that's 10 times better.
Like the date number.
Yeah, and so that will allow you to compare in your presentations. The p-value was like 0.05 for me, for him, but it was only 0.20 for me, and it's because I found this other column that was super helpful.
Good to know.
All right, thank you very much. Next group.
Hey, Kaden, can I send you mine so that I can just do it on your computer, because I
Sure.
have just this.
Really awesome person.
Oh, you know what that means? That means freaking Tyler is not gonna show me any graphs. Just gonna walk up there and give me words.
I'm sorry.
I'm gonna give you a marker so you can draw me a graph on the spot.
I haven't even made any graphs myself, so. I've made a model, I have not seen how it works yet.
Okay, so for our baseline graphs, this is the SQL query we ran. It selects all these columns, the dates, start, and destination, and takes the average of the fares and puts that as the average cost in our table. And it's from the fares table, where fare is not null and fare is not equal to 0, and the destination is not null.
So why did you put those is not nulls in there? Did you have, was there data in the group table where there were empty cells, empty values?
Yeah, there are a bunch of empty values in like the destination.
Yeah,
And
okay.
And then I had to put date in there because there was one where it was 2024, so I went.
Yeah.
And put that in,
And wait, and date is great, okay, is in 2025. Yeah, somebody mistyped it in, and so now their data isn't part of the system. All right.
And then where the destination was equal to JFK, and then you replace that with BOS or DFW for those different graphs, and the start you set to MSP because some people misspelled that to MPS.
Mm-hmm.
So had to clarify that, and then this date range because some of those were incorrect as well.
Well, you know what, if you know that somebody meant to type in MSP and they typed in, a lot of people typed in MPS, you can run an update query that says update start set. How do update queries work?
I fiddled around with it, so I don't know.
No, update table name. Update table name, set start equal to MSP where start equals MPS.
Okay.
And then you can use that data.
Okay.
And that will simplify your query here too a little bit, probably.
Okay. and then just grouping by the destination date and start, and then ordering it by the date.
And what are you doing with this? What is this giving you?
The baseline graphs.
A source table for
Those guys right there.
for JFK only.
Yes,
And
and then
we
you
just
switch it
list
out
out the values.
to get those other graphs too.
Yep, you change that
Yeah.
name and then you get the other two graphs?
Yeah.
And so this is just the baseline graphs doing that query, showing what it displays. It's the average of all of the things through our range, so from the 21st to the 20th.
So the actual data that we all collected, except you
Mhm.
probably averaged it?
Yeah, so it's just an average of all of the
Yeah,
inputs
right.
that fit within the parameters
Yeah.
in the query before.
So basically, you've got one fare per day for each one of those destinations.
Yep, that's great.
Built out of whatever data was available that was collected by people on that day.
And then for a prediction,
That's weird.
what, I'm looking at JFK.
Both JFK and Boston. I
JFK
mean,
was a little odd.
They're in the same sector of the country, so that makes sense. Because this is what I expect to happen to any airfare, and that's kind of happening for Boston. And yeah, I guess sort of. It's just super messy for JFK.
Yeah.
But you know, maybe JFK is a weird airport.
I found that one pretty odd too.
That's why it's good to start with a baseline like that.
I have a
See the
question.
weird ones right off the top.
Did you check for if fares were set to 0?
Yeah.
Okay, you
I
did
can
check
go back
that.
up one.
I forgot, oh, you did have that,
Yep.
okay, okay.
So, try to make sure, check all the boxes,
Mhm.
we had the right data, or the right data
Yeah.
that we wanted. So, and then for our predictions, our graphs were pretty bad. It's kind of a naive model. What I did is I just kind of checked to see how much each increased by, you know, kind of find the slope, move over one, go up this much. But checking that individually for each date is pretty bad, because like, for example, you see in the exponential parts, like in DFW, where the RSME is absolutely terrible, like it can go up a lot, and if it goes up a lot, it, you know, you see at the very end, it predicts it pretty well, but if it goes up and it goes down a little bit, it's gonna go below whatever the intercept was, which is around 400, which is just super off. So I have a few ideas if I wanna improve it, maybe like taking the average over a set amount of dates, or something along that line, maybe run a bunch of different, like.
What are your inputs?
My inputs, it's just first 25. I just measured how much each date increased by and kind of like went off that. And I'm thinking like,
So a difference value.
Yeah,
A single
pretty
input, just one input, one output?
yeah, so far. I'm thinking maybe you
So
can
difference between 1 day before and 2 days before you actually predict to buy the ticket?
it's just the day before, just like the amount it increased by per value. Which is
Yeah,
pretty-
but that difference has to be made out of at least 2 other values, right?
Yeah, you need 2 values, yeah.
What are the 2 values that you subtracted from each other to get that difference?
It's just the U's and V's. It's pretty naive because it only uses the data set we're actually working on. So it's literally just, you go down 1 column and you subtract it.
Let's say you're trying to predict, I want to buy this airfare to DFW on September 25th. And
Yeah,
I want to use a single difference to predict that. And the difference I'm going to choose is what, the difference between fare on the 23rd to the 24th?
Yep.
Yeah? And so maybe that's $50. How are you going to use the number 50 to predict a $250 fare?
yeah, no, that's something to look into,
Okay.
for sure.
What I'm noticing
Yeah.
is, and again, this is what this presentation is about. I'm not trying to make fun of anybody or make anyone feel bad. I just do want to point, to poke holes in your things before you
I know it's
dedicate the
pretty
entire
bad.
next week to
I'll
it.
whip this up in 5 minutes.
But this is a constant function, essentially. I mean, it's just a messed up constant function. It's really just staying at the same level, and so I feel like all of your differences are pretty much the same, somewhere between 20 and 50, and maybe that's
It only
what
works
this difference
if
is.
there's a major difference. Like you see the very last point in the DFW one, it works there, only because there's a major difference between the first and the last one.
Yeah, that's probably 2 days before the flight departure and then 1 day before, and so
So
yeah.
that's what I'm thinking, maybe I average, like, a different part instead of using just the previous value, that way you get a more set in stone and less random looking.
Yeah, well, you definitely want to use more than one input.
Definitely.
And if your one input is a difference, then it's just gonna give you something really constant until Until the last day, actually, that makes a lot of sense.
Because this would only really work for a graph that is continuously increasing without any dips at all. Which this obviously is not, so it's really
Yep.
good.
Yep.
So,
But yeah, definitely, and you know, I mean, it thinks that this was the easiest one to predict, your errors were the least here.
That's 'cause
because
it
I guess it
didn't-
changed the least. But yeah, you're actually trying to predict some sort of, it's not a hyperbola, maybe? What do people say instead of quadratic? Exponential. This is kind of an exponential function
Yeah.
happening right here. It would be perfect if we could just predict that with an exponential graph, but you know,
yeah, I need more.
our
than one
database
value.
doesn't know about that yet, so we're not doing fitting to exponential functions. We're trying to use whatever data we have to predict tomorrow's airfare for this flight that departs on the 25th or 20th of November or something. Okay. Anything else?
No, that's it.
That's perfect. Thank you very much.
Thank you. So, final presentation, it's me and Michael. Michael cannot be here because weather and, yeah, so I'm gonna be giving the presentation here. All right, so first step, obviously cleaning up the data, removing all the nulls and the fares that are equal to 0. We have a error finder. We have an error finder SQL statement right here that kind of removes when most things are null and when the fares are 0 and stuff like that. He said we removed about 300 data values.
300 rows?
300 rows of data. So, like you said, the checking the MPS versus MSP, possibly doing that to see like, okay, maybe some of these can be like salvaged and
Yeah.
just fixed. And then we added in a few columns for like date, time, year, and day of the week. So we can tell like, okay, this flight, we're checking the time, this flight is it's being, the time that we're checking it is a Tuesday versus a Wednesday
Yeah.
versus Thursday.
You know what's weird about that though, is how do you have day of the week encoded? 0 through 6 or 1 through 7 or?
I'm not 100% sure. He's done a lot of this. I'm kind
Okay.
of trying to do a little bit of catch up, trying to understand it.
Because what's weird is when you go from Sunday, I don't know,
Oh, the calamity.
Saturday to Sunday, from day 7 to day 1,
Mhm.
that fucks up the math for the predictor. Why we increase by 1 day and it subtracts by 6, that makes no sense. And so it's at those endpoints that the math could get wonky. And so you could actually be introducing weird stuff happening during your weekends that has nothing to do with it being a weekend, but just because you encoded them as numbers. But if he has experience in this, he may have figured out a fix for
He
that.
might have figured out something to specifically. I'm kind of just trying to, recap what he's been doing. He's gotten very far into it. We're using FAIRS 19, 21, 23, 25. We're using FAIRS 19 and 21 for the training data because there's a lot more values in those two than the other two. Like, I think he said FAIRS 19 has over like 4,000 different rows of data. And compared to 25 where we only have like 1,800 after the cleaning process.
Mhm.
So it's a lot more data to train on.
Yeah.
So our FAIRS 23 and 25 is our testing data set, and then we separate that into 3 subsets for each flight, like the MSP each flight like destination. So 1 to DFW, 1
Man,
to.
you are
US.
using COVID area data as your training set? And so it's gonna predict 23 and 25 years as though COVID were happening?
I guess
You're
that is.
baking in COVID patterns in your training set is what I'm saying. Okay.
Do you think it'd be better if we tried to take out 19 and 21, or what would you suggest with that?
I would throw everything into one massive table,
Yeah,
19 through 25,
I-
and then randomly select half and make that the training set, and then the other half is the testing.
okay. I'll have to bring that up with him. Here's his.
I mean, there's problems with that too, but it's not as bad as pretending everything is like in 2019, or even worse, 2021.
Yeah, here's his SQL query for that.
That you
It's very small.
are messing with me with your colors.
I know,
Yeah.
think some grays and some blacks and whites would have been a little better. You got all that?
Yeah, sure.
Alright.
So yeah,
So-
you have about 5 inputs
Yeah.
there.
And it's still a lot of, I'm still trying to understand what all we're gonna be doing, cause like I said, he's gotten very far ahead
Yeah.
into this and I've kind of,
The 10-point time series did the best job, and
Yeah.
that's probably a pretty good baseline, because hopefully whatever you come up with will be
And then you-
better than 10-point linear regression.
he has this plan for the spatial analysis where, the reason why we got the days is trying to find a pattern for which day of the week is the best day.
Yep.
And he has, a whole set of things that he's gonna be doing for that.
Yeah, good.
I believe he's got like 3 or 4, data points that we're gonna be using, instead of just like 1 or 2. So hopefully it should be a little more accurate, and just for you, Francois. Oh wait, here's some graphs. But I do wanna say first though, what we've done so far, there's a lot of holes in the 2025 data. I asked if he like averaged it out, and I don't think he did, so we might try to average it out so we have like everything to one day. So all of the like there might be 5 points for this hour, but 0 points for the next, or something like
I
that.
bet he's talking about the 10-point prediction series.
Mm-hmm.
If people really only collected data Monday through Friday and nobody collected during the
It might be
weekends,
the Saturday and
then
Sunday
you're
holes.
never gonna be able to get 10,
Mhm.
a continuous series of 10
That-
fair values.
That could be, we may just do we only fairs 25, we still need to do a bit of refining on the process. I think we've really started working on the past couple days on it, so it's very bare bones, but we do have some graphs for you of all the,
Alright, so, oh my god.
I know, it's very small and it's very,
So what is the blue line?
blue line is, DFW 19, and the orange line is DFW 21, and then it's Boston 19, Boston 21.
What?
It's just tracking the fares over the,
So these were the fairs in 2019,
Yep.
and then these were the fairs in 2021?
Yep.
You're not using, so this is August through like, October, and then this is November through December or something? I mean, these are just numbers along the bottom, so I have no idea if those are dates or whatnot. This is why we label our graphs.
Yeah.
But I assume that these are fairs.
I think,
Oh my god.
yeah, there's a lot of,
You did not average values out, it looks like.
no,
What
I
the heck
think
is
that-
this? Oh, somebody,
I
it's
think
like,
I think there's
people
a
didn't
decent
collect
amount of
during
space.
Boston except, okay.
I
So I
think
have
there's
no
a
idea.
decent amount of, I think the numbers on the bottom are like, this was value number 1, 2, 3, 4, 5, and then it's going over.
Row numbers probably.
Yeah, so it is not aggregated, it is not set up the best. It's still a work in progress,
Yeah.
we're still working on it.
Well, I guess what you're telling me is that you have twice as much 2019 data as you have 21 data.
Yeah, there's a lot of 2019 data, not a lot of 2021, and I think even less 2023
Yeah.
and 2025.
Yep.
So,
Yeah, some people earlier on actually set up their computers to query the Google servers every hour or
Mhm.
something, so some
Yeah,
users
we-
have a whole lot of data through APIs.
yeah, I think Justin, in the 2019 or 2021 had like 2,200 data points just on his own, which was more than our entire data set.
It's better than copying stuff down by hand.
That is true, that is true.
I wish I had done that.
If your computer's on
It
24
was hard,
hours a
trust
day,
me.
make it do the
Try to
grunt
deal with
work.
it. Yeah.
Thank you.
Yeah.
And thank you, King, for providing that.
All right, who's next?
We do not have.
I'll take a
we don't have
different poll.
slide to go. I didn't think I need to make a slide for this
If you
one.
think your PowerPoint's bad, we don't have one, so.
Yeah.
We're just gonna try to spitball what we have. Oh, you can write something to the board?
Well, I can't if I
He's
need
making
to.
a graph.
He's gonna make.
Sam,
Yeah.
data. Well, I'm not.
Let him graph it for me.
Well, I was gonna write out how we collected our data. I haven't looked at our graphs yet, so
No,
I've like made a model.
Yeah, so we're in trouble actually making the model. So like, I mean, all of your queries were kind of the same as ours. For at least for DFW, we were doing it on just like Delta. There was a lot of Delta flights from from Minneapolis to DFW. So we were trying to predict the Delta flights. So we had two queries. One, get the one certain flight we want to predict, and then we had another query to get the rest of the Delta flights. So we have one flight that we're trying to predict, and we're trying to predict it with the data from the other 3-4 Delta flights.
Did you average those flights
Yes.
together? Okay.
Yes.
That's one of our points.
That was one point.
specifically.
Yeah.
So we have a main flight, I'll just call like 2870 or something. So we have this, and then we have like a bunch of rows for data. That's our prediction one. And then we looked at all the other Delta flights, like we said, all the other Delta flights at the same time. That is not a large enough box where the flight number is,
So
say, like 28.
Is each individual average flight number an input? Or did you average together all of the other flights into a single input?
I have, so, we looked at all the Delta flights, from a specific route. I have, and then I looked at each individual flight, or I took 3 of the individual flights, I'll call them, so we have this, and then we didn't like, averaging is one of the things, but I wanted to see how the raw data values did as well. So this is the one we're predicting. I'm not looking at this one at all. It isn't included, but I do look at
Those 3 values to get the first value.
to look at how it compares to this.
The row of values
Yeah.
are
So
your
like,
inputs?
so like this is this is like a specific day, or this is like day 1 or whatever.
Yeah,
This
kind of, we need to have date as one of our inputs.
Because the
That's
problem.
gonna be important. That's why I like Dane's, model explanation.
I do have
Date
a
until
date.
departure serves as that.
I do have a date thing, but I don't use it in my model yet, so I will
Because
have that.
the key problem with this is that there's certain days where the flight that we're trying to predict is not there. So we can only have one flight or 2 flights to predict that one flight.
Yeah.
Really, because the prices were relatively the same with Delta. Some were higher, some were lower, but they were really around the same range. But still, when it comes to a bigger graph, it could probably still cause problems.
One thing that you did bring up, the holes in the flight I found to be a pretty big problem, because there's a lot of rows where it doesn't have all those 4 values.
Yes, so that is definitely a problem that you encountered.
Yeah, so I'll need to fix that at some point, or find some solution around it.
Or scrap pieces different.
Yeah.
So it seems to me like we're using data fares from flight 2830 and 2970 and 2971
Yeah.
to predict the fare for 2870?
These aren't the exact numbers.
Yeah,
but
sure, but-
yeah.
And so you're saying some days you only have 2 of those fares and other days you have 3?
Because of the query.
Yeah,
that I have,
so this model is only going to work when you have all of your inputs there, and that's one of the things that averaging does, is if you average all of these into one, then you never have to worry about that.
Yeah, I'll do that then.
But it is nice to try to build more specific models like that.
But yeah, what we can't have where all 3 of them are there, but it lowers the.
I'll have to. All right, well, what I also did, on this is I took the mean of, I found the day prior to these as well for each in another column, and then I took the mean of all those. That was a really good predictor I found. Its p-value was like 0.01. Some other good predictors were just the prior days for 2 of them, just very close to each other. I tracked the change over like the last 1, 2, 3, and 4 days, and then summed them together, and I just threw all of them in the prediction model. But I found out none of them were actually very good predictors. So that was
Differences, always disappointing, I've found.
Yeah, no, they didn't.
But the books keep on telling me, use differences, they're great.
Yeah, and I was like, I thought they were gonna be good, but they really weren't. And then it also, I got like, not only did I get after this, I got the 2 days prior and 3 days prior of this, and I made like a linear model of these each. So like I made a linear model for 2830, for 2970, and for 2971. And then I used those and threw them in my prediction model, and I found one of those was really useful. It's the other two p-values, when I eliminated two of them, one of them like went way down in p-value, so I think there is some overlap. Because that's usually how the models work. If there's overlap, then all of them will have a high p-value, but if you eliminate all but one, its p-value will lower a lot.
Make sure in your final presentation that when one of those models gives you a really good p-value, that you show us the expression that is generating that.
Yep, I think averaging will help that a lot, since that'll reduce all the overlap too, I think.
But another problem with this is that, like, this is just for DFW. When we get to the Boston and the JFK, well, how many flights are gonna be exactly the same? I haven't looked yet, but again, there is the pitfalls of not all the flights being on there, because not everybody's doing this every single day, which is fine. So we have to figure out that, but I'm pretty sure it'll be relatively fine. Even if you have to make it down to 2, it probably will still be fine. So
yeah, something interesting also is that Minitab told me my R-squared value is 99%. I think it's because one of the flights had almost identical values to this, but one day was off.
Yeah.
So,
because with Delta, all the flights were relatively around the same price, other than some weird single dollar price differences. So, but still, it's something. And I don't know if they did first class or whatever.
Yeah, I mean, you would expect, they're all flying from Minneapolis to DFW, say, and so you would expect that the price would be pretty much the same.
Yeah.
For every day along the way, except for if they figure that people will pay more to leave in the morning and have the day
that was the
spent
biggest thing. Because you go to the flights.google API, and
the cheapest ones will leave at 11 p.m. at night.
Because when you actually look at that, like the price difference was like 300 and or 700 coming back just for different times. I was like, what's the point? And you're in the same cabin too, so people could have picked different ones too for going to the same place. So.
One other thing that I noticed about your model is if you're not using the date, if you're not using days until departure, what this model is predicting is when the values of these flights are these 3 things, then usually the value of that flight is this thing. And just having a date saying we're 50 days out, or we're 100 days out, or we're 2 days out might actually add some power, add some juice to what these 3 inputs are already doing.
All right, okay. I'm gonna make a note of that so I don't forget. I think my plan because I just did stuff on Dallas, because I figured once I get all the stuff figured out on Dallas, I can kind of just apply the same idea to the other 2.
Yeah.
And then just like, I'll want to rerun and kind of remake the model to make sure I select the best predictors for that. But I don't think, once I get it down for one, I don't think it'll be that hard to make for the others.
I see no problem, other than some weird stuff there and there.
So that is ours. Unfortunate lack of graphs in a PowerPoint, but
even if it does PowerPoint, I don't know if we would explain this on there.
And if you'd like to build a model that focuses in on 3 specific flights, maybe for your Boston data set, you choose these other 3 flights that Regressor says is really good. Still, as an addition to your dates until departure input, put in a 5th input of the average of all 3 of these flights, or as many of these flights are available, or maybe just the average of all the flights to Boston.
Okay.
But put an average in there, and that's also one of those smoothers like days until departure. Days until departure is going to be.
Okay.
Yeah.
We can do that.
Actually, I have a question.
What's your question?
So is it like you're specifically choosing Delta flights? Are you gonna try to check any other airlines, or?
Not really. Delta was the biggest block that we used. American Airlines, because some people only picked like going from there to, let's say they picked Delta there, but they're taking the American Airlines back. We can't really use that, but Delta was the majority people use, so we're using the biggest data set. So I mean, you could do other flights, but like,
you pointed out a problem with delta-only flights, though, is it's kind of a naive model in itself.
Yeah.
Mm-hmm. And I'll have to play around with it. My some of the thought process that went into it was that making including other airlines would make it have a lot of variability. So it might make the model worse. So I'm like, all right, we'll focus in on Delta and see how it works there. But yeah.
And by the way, when you're using input 2830, say, and 2970 to predict a 2870, you're not using the fare from the day that you're trying to predict, right? Those are all the day before, and you're trying to predict day zero fare on the outside.
Yeah,
Okay,
because
on the outside.
it's probably the same day.
Yep.
Remember, you can't predict the same day.
Exactly.
So, yeah. Questions? Whatever.
Yeah. All right. What do we have left? Feels like only one or two groups.
All good. Okay, I also thought that it said oral presentation on the assignment,
Yeah,
so I
that's what I
carried it. It'll be very quick, because lots of happened this week, so I only ended up making the actual table. I just combined 2025 and 2023, because I didn't want to use 2021 or 2019 because of COVID. And I was told that before that it was formatted differently, so I just did those 2 years. Got rid of all the extra data, or the things that weren't formatted correctly. I'm planning, now that I've heard that they might have just misspelled, so I'm gonna check through that, add what's needed, but I haven't really done any of that yet. So, yeah, I got that's it.
Yeah, that's the problem with an oral report is we have nothing to see.
All I do is combine, just make one table, that's all I do.
Yeah.
Quick draw table.
Yeah. But that's fine. If that's your report, do we have anybody else who needs to make a report? Go on ahead, because we only have like 2 minutes left. Now I've got something to see. Something to critique.
Oh, I forgot to add a table on this side.
Ooh.
Yeah, I might.
So I don't have a huge amount done right now. I've been pulling data from 2025, checking it, just how the simple linear regressions, how it compared to them. This is just 2 days back. I checked 5 days, 1, 2. There's obviously a lag you expect. I have been looking at.
Why would we expect that lag? What's your inputs?
I'm using the same linear regression systems we used back for the first wing data.
3-point.
Just to see how they compare,
Yeah,
to get an
absolutely.
idea. I've been pulling just the Boston data mostly and looking at it.
Yeah.
I am looking at the width of max and min to see if I can do anything with that. So I've been pulling that and plotting it, but I need to pull previous years to build the model and still actually see if there's a good way to use this stuff.
Yeah.
So
Max and min might be good, but as I think Tyler said, mean or mode. Did you say mean?
I said mean.
That's just
yeah.
average. Okay. Well, average is good, and mean is the same. But yeah, mode would probably. No, mean would definitely be better than max and min, but I expect that each one of them would have some improvement to them. Maybe use all 3. What the heck? See what the p-values are and throw out whatever's useless. We'll tell you to throw out max and min, but keep mean.
and that's what I've got for now.
Oh,
Okay.
Matt, would you mind if I use
Yeah.
your computer to plug in my flash?
Go ahead.
Okay.